Teşekkür ediyoruz. Yangın direnci test programından elde edilen sonuçları paylaşarak yapı elemanlarının yanması sonucu açığa çıkan dumanın miktarı ve potansiyeli toksik etkileri hakkında potansiyelin toksik etkileri hakkında bilgiler vermesi üzere modern hafif yapı elemanlarında yangın güvenliği sağlamanın kriterleri başlıklı sunumunu yapmak üzere özür diliyorum. Rockwool International Yangın Güvenlik Müdürü Sayın Miroslav Smolka'yı sahneye davet ediyorum.
Good morning. My name is Miroslav Smolka. I'm pleased to be here for the first time for me in Turkey. I'm a fire safety manager for the Rockwool group. I'm coming from Slovakia, and what I will present today are three types of constructions from the fire safety viewpoint: sandwich panels, flat roofs, and external insulating systems for walls. Before joining Rockwool, I used to work for 8 years in a fire testing laboratory. That's why I can combine experience from both sides, from both of the worlds, let's say. So what I want to cover by this presentation is some basics about fire development, then a reaction to fire, including reference scenario, fire resistance, and last but not least, importance of details. So if I may come back to the very basics, why do we have two pillars of fire safety, two systems of evaluation? What you can see here is a typical development of a fire in a room. When a fire starts, obviously it starts as a small fire, and if there is enough oxygen and enough combustible materials, the fire grows, and when it reaches so-called flashover stage, then it develops to a fully developed fire. So here in this part, we are concerned with reaction to fire testing, and we are measuring both materials or constructions, but using a small fire exposure and measuring things on the fire side. But now, when we pass the flashover stage, what we are concerned about is resistance to constructions to fire, and we are not concerned about what happens on the fire side because everything is in fire. But what happens on the other side if people are safe on the other side? So what is actually this phenomenon called flashover? This is the transition between two stages, from small fire to fully developed fire. Obviously, no one can survive it because you have temperatures more than 600 degrees after that. And since all oxygen is consumed by the fire, smoke toxicity increases after that. Of course, not every fire reaches this stage. You can have a small fire which just dies out without any big development. But according to some available statistics from the United Kingdom, as many as 30% of all fire cases develop until this flashover stage and to fully developed fire stage. I think it's quite a significant amount. So if I may continue with more specific construction with sandwich panels as a representative of lightweight, modern construction, we can ask what panels are fire safe. Of course we can say everything which meets legal criteria for a specific application is considered safe from legal viewpoint. If you look at reaction to fire test results measured mostly by this SBI test, you always get A2 or B, sometimes C class, regardless of insulation or combustibility of insulation, which is in between the steel sheet. If you look at fire resistance, there are bigger differences. With stone wool cord sandwich panels, you can have at least 30 minutes, you can have as long as 6 hours with using combustible infill like polyurethane or PIR. You can achieve from 15 minutes to 30, sometimes even 60 minutes. It's important to mention that this is not for sandwich panels, this is for walls made of sandwich panels as a complete construction. If we ask as a user, what panel can I consider fire safe? Well, I can get a different reply. Of course, if the core is non-combustible, the construction is non-combustible as a whole, and the panel is safe at any fire, at any conditions. Otherwise, there is a risk of flashover. Here you can see the example of the flashover. And you have significant smoke emissions, not only on fire side, but also on the other side. I will show you an example later. So, the Euroclass system or reaction to fire system is based on some scenarios, on some assumptions. First, we want to know what happens in a real fire. That's why we perform fire tests. But we can't measure real fire. That's why we create a model. We create a reference scenario and a large-scale reference tests, and then we have these small or medium-scale tests to simulate what will happen in a large-scale fire. So, for reference scenario in Europe, we have a fire in a room, and large-scale reference test is room corner test, ISO 9705. But what we commercially measure is SBI. It is a smaller version, and it is assumed that there should be a correlation between SBI and room corner, so that we can expect what happens in a larger scale. But is this really true? May we start the video now? I will now show you a room corner test made in an official fire testing laboratory. So first, what we will see here is a stone wool core sandwich panel. The principle is similar to SBI. We have a burner, gas burner, in a corner of a room, but we also have a closed room with a ceiling, and the output, the heating power of the burner is 100 kilowatts. In SBI, it's 30 kilowatts. So this is more realistic, and after 10 minutes, the heating power is increased to 300 kilowatts. So as you may expect, nothing really happens to stone wool core sandwich panel as non-combustible construction. Now you can see the flame gets bigger. After 10 minutes, it was increased 3 times in power. It starts to attack the ceiling of the room. And the test should continue until 20 minutes. So now we are at the end of the test. We can see some smoke coming from the glue between the panel and between the steel and the insulation, from the coating, from the paint, but there is really no big damage apart from this damage to the surface. And let's look what happens to polyisocyanurate or PIR core sandwich panel. The first panel, stone wool core, is mostly classified as A2 class. This panel is classified usually as B class. So you might expect, just looking at the figures, at the classifications, that there would be no big difference between them. But is this really the case? Obviously, there may be no big difference if the fire exposure is small. But if the fire grows, you can see a much higher amount of smoke here coming to the fire site. And now, as the heating power is increased to 300 kilowatts, the height of the room is 2.44 meters. We can see that something is starting to happen here. We can see opening of the joint between the panels, and now at this stage we can see that not only product itself, but also gases which are coming out are starting to burn. So now we are coming close to this flashover phenomenon, when at certain point in time the whole volume and whole surfaces in the small room starts to burn. And this will be the end of the fire test of Of course, because these are the conditions that no one can survive. Even here before flashover, we can see a lot of smoke. And you may know that from polyurethane-based products, we can see most toxic smoke here. So this is the moment of flashover. And at this moment, we are not concerned anymore about what happens to construction. We start to be concerned to what happens on the other side. Because everything is burning inside, but the question is what happens to people who are supposed to be safe in other parts of the building. So you can see that it's not easy to extinguish, even though it's only 30 square meters of sandwich panel. Okay, so we are at the beginning again, so you can stop it. So the Euroclass system in Europe is based on a criteria of flashover. That's why we have so strong dividing line here between non-combustible products and combustible products. The real difference is if the product can contribute to flashover in this reference room or not. And what are the reasons for this kind of performance behavior of sandwich panels? The first reason is that the fire protection is only a very thin steel sheet, which does not prevent heat from coming through to the insulation. Now we can see as thin as 0.4 millimeters thin steel sheet here, but it's not integral. It has joints, and these joints are never perfectly tight. So they deform, and combustible gases can come out from these joints. If I shall look now at fire resistance, we expect that fire-resistant walls and partitions and doors are created to protect people on the other side. If we performed a test on a typical stone wool core sandwich panel and a polyisocyanurate core sandwich panel, you can see the fire testing laboratory, fire resistance testing laboratory, and the laboratory operator measuring gaps between the panels, and the same guy measuring something else with polyisocyanurate. This was only a couple of minutes after the start of fire test. And the principle of the fire resistance measurement is that you have a testing furnace when you want to create some kind of high temperature curve over time. So this is the standard temperature, the blue one. And the laboratory is trying to simulate or to follow this curve. But if you have a lot of combustibles, it is not just possible. It is quite common that the contribution or burning of the construction itself is so high that you have a very high temperature overshoot. It's much higher than the standard. It's simply not possible to control. And if you look at this example, you can see what happens on the safe, unexposed side. So after 4 minutes, we can see a significant development of gases. These gases are not coming from the furnace. These gases are coming from the construction, from the insulation infill. And can you see now the clock? It reads something like 6 minutes, so only 1 minute and a half later. And despite the strong smoke exhaust system in the laboratory, it is not just possible to stay in the testing hall. And still, this construction meets the criteria for fire resistance and legally is considered to be safe. Somebody can say it's still fire safe. On the contrary, if you look at stone wool core sandwich panel, this is a picture of what happened after 1 hour of fire testing. So we have almost no smoke here. There was some small failure here, very small flame which died out by itself, but nothing else. So completely different level of danger. Fire safety is always about danger, about risk. You can never eliminate this risk. You can ever do what you can to decrease this risk. Of course, if you have a nice fire test result, you can achieve it with a construction built in a test furnace, but it may be quite different what happens in real life, in real buildings. I cannot stress more that quality of installation, this is the paramount. This is the basis of the construction, that it performs in the same way like it performed in the fire test. If you look for example, at a joint of a sandwich panel, you can see in this example there was a combustible core, and it was used special sealing tape from Promet company. And what you can oftentimes see here is the small screws or rivets. They are very important from a fire safety point of view. If they were part of the tested specimen, they have to be installed on site, although investors don't like this kind of screws and rivets. But they are very important, believe me. If you don't use them, you can experience much less fire exposure. So these are very small details which all people involved in a building process should be aware. These small details are there because of fire safety. And if you look at a classification report or a certificate, a very typical information which you will see here is something like this. EI15, for example, BS2D0, so fire resistance class and reaction to fire class. But it's very important to understand what is behind, what these figures represent in reality. So what we have here is information about integrity and insulation. So we see that for 15 minutes, this product didn't allow flames to pass through, and the temperature was within the limits of 140 degrees on the safe side, on the unexposed side. What we can see here is a relatively good reaction to fire class, but this was measured at low fire exposure. But what we can't see here on this classification, on this example, is this dense smoke on the safe side, which may start very early, from the first or the second minute. These gases are combustible. These gases may be highly toxic. And it's a fact that smoke and heat release in these kind of products just can't be predicted. There is a big degree of uncertainty what will happen in real life here. So just to summarize what I want to say today, sandwich panel is a new construction. You can see it more and more, not only on industrial buildings, but also on common dwellings. Reaction to fire class doesn't tell you anything about smoke toxicity. It only tells you something about smoke optical density. How much can you see through the smoke? And fire resistance, you can have some information about penetration of flames through the construction. You can have load-bearing capacity information. You can have information about insulation characteristics, but nothing about smoke really. Can we now show the video? What I will show you now is a short video showing fire resistance test, including installation process. So this is a test according to European standard 1364 part 1. This is non-load bearing walls. And what we tested was a couple of different products. They were different sandwich panels. So here you can see the test frame.
No týchto nie sú zaznačené, ale budú pod slovami.
And you will see how these products are installed in practice. The goal should be to simulate the real life installation as much as possible. You can see stone wool is used in fire testing laboratories quite commonly to seal any kind of gaps, to prevent direct attack of flames on the insulation core. Of course, the installation should be made the same way like it is done in practice. And now these panels are screwed to the steel load-bearing construction. So there is a load-bearing element on the top and on the bottom, steel profile. And this steel profile is insulated from fire, usually by stone wool. So that you don't have any deflections, any deformations during the fire test. And it's very important to seal any kind of gaps so that fire can't penetrate through this construction. So this is what the construction looks like before the test from the exposed side, and here from the unexposed side. So what we are going to measure here on this wall are temperature on different points. We are going to measure deformation of the panels. So now the laboratory operators are applying thermocouples to measure temperatures on certain points, which are prescribed by the test standard. And sometimes we also measure radiation or heat flux for constructions which are on exterior walls. And now fire test begins. We could see what happened inside. And can you see the time? It's only one minute after the start of the test, and the smoke is coming from this construction. This smoke is falling down, so that you may expect that it's cold at this moment, but here it's becoming hot and it's changing colors. So we really don't know what kind of gases are coming out from this construction. So we are now on the safe side of the structure, and this is not a problem for fire resistance test. But this is quite commonly seen on fire testing like this one. We can see some small flames here, but this was not considered a failure because it was not through the panel or through the joint. It was between the frame and the panel. So this is what you may experience, or what may happen in a real fire just after 4 minutes. This construction was supposed to be classified for much longer fire resistance period. So what are the criteria which we evaluate? We evaluate temperatures on the surface, we evaluate integrity, we are looking for small flames, but we don't care about smoke at all in this. So now this will be going much quicker, 5 minutes, 7 minutes. And in spite of the fact that the laboratory got air inlet and outlet and a strong ventilator, strong fan, it was just not possible to get all these gases out of this test hall. And a failure happened shortly before 12 minutes. But it was only after this very long period of intense development of smoke. Of course, it was forbidden to go inside the test hall because this might be highly toxic gases. So you can see that even the laboratory technicians were only able to enter this hall only with breathing equipment. And this is what remains of the insulation core after the end of the test. This panel is classified as B reaction to fire class as well. What we'll see next is of course, stop it now. I think this might be all about sandwich panels. I will not going to show you the pier, the Rockwool core sandwich panel. Now, isn't there time for a coffee break? And after the coffee break, I will present flat roofs and ethics. Thank you very much.